Okay, welcome back everyone. In this video we're going to talk briefly about the law of reflection. And so the actual math behind it is fairly simple. It says that if you have an incident ray coming in and hitting a reflecting surface, that the angle theta 1, which this incident ray makes with the normal, is equal to the angle theta 2 that the reflected ray makes with the normal. Now this is important enough that I want to make a point about it, is that all angles are measured between the ray and the normal. And just as a reminder, when we say normal, what we're talking about is the perpendicular to a surface. So again, the law of reflection simply states that theta 1 equals theta 2, or another way to write it is that theta incident equals theta reflected. And whether you use a 1 or a 2, an I or an R, doesn't really matter as long as you understand what you're using in which scenario. Okay? So there's a couple of other things I want to mention about reflection in this video. First of all, the law of reflection itself, theta 1 equals theta 2, is extremely simple, but the actual details of what happens when a ray of light strikes a surface which is made of molecules, which is made of atoms and electrons and nuclei, is very complex. And in one of the optional videos, I'll talk a little bit about what the great physicist Richard Feynman had to say about reflection. But it's important for you to realize that this simple result comes from something much more complicated. So that's the first thing. The second thing is that when we talk about reflection, there's a couple of different types. First of all, we can speak of so-called specular reflection. And this might be related to spectacles. Kind of the same word etymology. So this is where you have a surface which is smooth and flat, and what happens is that reflected rays that come from parallel rays are themselves parallel. And I realize that sentence may not make a whole lot of sense, but think about it this way. Here's a mirror, here's a bunch of incoming parallel rays, and what I can do for each of those rays is make some sort of a normal, and because they each obey the law of reflection, the reflected rays will emerge parallel, and they're supposed to be the same spacing as before. Okay, so hopefully I did an okay job with that drawing. Okay, but for all of these, theta 1 equals theta 2. So incoming parallel rays are reflected and are parallel afterwards. We can contrast this with another type of reflection, and we call that diffuse or irregular reflection. And in this, basically what happens is that the surface is rough. So incoming, I'll just write it like this. So parallel incident rays are not reflected parallel. Now this is how we see most objects. For example, it's how you read the words off the page of a book. Well, you might be wondering, I mean, the page of a book looks pretty smooth to me, So, for example, pages in a book. It looks pretty smooth to me, right? But when you think about the wavelength of light, the wavelength of light is on the order of something like 400 to 650 nanometers. And if you think about a little wavelength of light kind of wiggling and coming in, okay, maybe that's not the best drawing, but here is a surface that's kind of a little bit jagged, and if you have parallel rays that come in, when I hit the surface, well, they're going to obey the law of reflection. So theta incident will be equal to theta reflected. But the thing is, the normal here might look like this, the normal here looks more like that, the normal at this point is kind of like so, the normal here looks like that, and the normal here looks like that. So that means that these reflected rays, okay, get ready. Let's see, let's do blue. No, I lied, let's do black. So that one goes like that. That was pretty bad. Okay, this one goes that a ways. This one's going to kind of go up like that. This one's going to go back that a ways. This one will go something like that. So those rays are clearly not going to be reflected back parallel. Okay, so diffuse and irregular reflection actually happens quite a lot. We just don't really recognize it as such. Now the book has a neat example of how a surface can turn from diffuse reflection into specular, and that is what happens to roads when it rains. So there's a picture of a road when it's sort of dry, and you can just see, you can't really see reflections very well, and then all of a sudden it rains and the rain fills in all the little pits and irregularities in the surface, so it kind of levels off the surface, and now all of a sudden you're going to have specular reflection. And so that's why on a rainy night you often see reflections of all of the lights in the road, the headlights, tail lights, etc. Okay, and that's pretty much it. Next video, I'll show you a quick example of how to deal with the law of reflection in a problem.